This question is asking us about a relationship between the wavelength of light and its energy. And the question is not particularly well stated because it is actually the energy per photon or the energy per particle of light which is being asked for. So let's just briefly take a look at that. If we have light particles, then particles of light are called photons. And if you happen to be a Star Trek fan, you will remember that Captain Kirk was forever launching photon torpedoes against people. So these were explosives made of particles of light. Okay, well, back to the real world. And the energy of a photon depends on its frequency or its wavelength, according to the equation that the energy of the photon is equal to Planck's constant times the frequency. Now, remembering that the velocity of light is equal to the wavelength times the frequency, and therefore that dividing both sides by wavelength, frequency is equal to c over lambda, it's clear that we can also write the energy of a photon or light particle as being h times c divided by lambda. And both of these are forms that you should remember. What is h? H is a number with units called Planck's constant. Planck was a German physicist who first discovered this constant by considering blackbody radiation. And if you want to know about blackbody radiation, a Google search or Wikipedia will prove very informative. So h is called Planck's constant, and h has the numerical value to three significant figures, 6.63 times 10 to the minus 34 joules times second, which is called a joule second. Okay, so after that brief introduction to the particle theory of light, we can work out the wavelength of light that has an energy of 7 times 10 to the minus 19 joules. We will also need, as we want the wavelength, the velocity of light, which you will remember to three significant figures is 300 times 10 to the 6 meters per second, also normally just written as 3 times 10 to the 8 meters per second. So it's a one-line calculation. We have E equals hc over lambda. H and c are known. The energy is known, so we want lambda. So therefore, cross-multiplying, we get that the wavelength is equal to hc divided by the energy. And that calculation will be 6.63 times 10 to the minus 34 joule seconds times 3 times 10 to the 8 meters per second divided by the energy, and the energy is 7 times 10 to the minus 19 joules. So let's just check that we're going to end up with the right units before we do anything else. Joules, top and bottom, cancel with one another. Per seconds cancels with seconds, and we're going to be left with an answer in meters, which is what we want. And irritatingly, I've run out of space, so let's make a little space and we'll continue this problem at the top of the page. And apologies for the amount of time this is taking me. So calculating those numbers. So the numerical answer is equal to 2.84 times 10 to the minus 7 meters. And as we've seen, most answers for light are expressed in nanometers. Most wavelengths are in nanometers. So if we want to make the substitution, then we need to know that a nanometer is equal to 10 to the minus 9 meters. Therefore, dividing both sides by 10 to the minus 9, we have nanometer divided by 10 to the minus 9 equals meters. And we can make a direct substitution. So that gives us 2.84 times 10 to the minus 7 times a meter. And we now know that a meter is a nanometer divided by 10 to the minus 9. 10 to the minus 9 on the bottom of the fraction becomes 10 to the 9 on the top. So this becomes 284 nanometers. So the wavelength that we were asked to calculate for light of an energy with 7 times 10 to the minus 19 joules is 284 nanometers. Make our answer nice for the examiner. And before we're done, just say, is this answer reasonable? Well, it's semi-reasonable, because if you remember, we know that the wavelength of light extends from 400 to 700 nanometers. 400 is at the violet end of the spectrum, so although this wavelength is reasonable, it's actually an ultraviolet wavelength rather than a wavelength of light. So again, not a very well formulated problem. Anyway, we're done.